Oh, good morning, all. um, so this is where we left off last day, talking about the three ways that you could transfer charge. Talked about um, uh, conduction, induction. What was the other one? Forgot already. On the other page. Oh, like friction, just rubbing. Okay. Before today's going to be a more you-directed day. Today you're going to be reading and completing questions on the following pages. And we're going to get to insulators and conductors in a minute. But before we do, just want to step back in time and talk about electrons to begin with. So when we're talking about electrons, if this was an atom, and this is the nucleus, so we have protons and neutrons in the nucleus, and then you recall that in the first level we'll have 2 electrons, and then in the next one we'll have, say, 8. And 8 again. And these shells are all filled. When we're talking about electrons moving, we're not talking about these electrons that are in filled shells. Once you get onto the shells that are unfilled, way out there, and metals have many, so there's going to be many layers. It's these electrons, it's these outside, we call them valence electrons. These are the things that move. Okay, so the farther, the more electrons you have in an atom, the farther the valence electrons are away from the nucleus. What that means is that when you get way out here into the nether reaches of space, these electrons are held very loosely, and so they're the ones that are removed. They can move around very much more easily than anything closer. Okay, so when we're talking about insulators and conductors, an insulator is just a substance in which the electrons are so tightly bound to the atom that they are not free, or they are unable to move. Okay, so that's what we're talking about here. Okay, so let's fill that in. A substance in which an insulator, let's highlight that word. An insulator is a substance in which the electrons are so tightly bound to the atom that they are unable to move to a neighboring atom. Okay? For example, plastic is a carbon-based critter, and so the carbon has very is very tight. The atoms are quite tight to it, and so that's why we coat electrical wires in plastic, because they won't conduct electricity. Other things such as rubber and glass are other examples. Rubber is also a carbon-based thing. Glass is a silicon-based thing. So these are all smaller atoms. So their electrons are very tightly bound. Okay. On the other hand, conductors, highlight that word. conductors is it allows electrons to flow freely from one atom to another. Okay? Just the converse, okay? So a conductor allows electrons to flow freely from one atom to another. Metals are good conductors. Okay? So don't want to think about this, but if you have high enough voltage, humans can also conduct electricity, which is not good. High enough voltage. A human is actually a good conductor as well. We're talking high enough voltage. One of the things that would probably pop in your head is, for example, a lightning strike. So you don't want to be in the path of that. Okay, and my son, who is an electrician, he actually showed me a video where a worker was working in a substation, electrical substation, and the components are stored in roll-out cabinets, and something went wrong, and there was a flash of very high voltage energy, and literally the guy was vaporized. You didn't see him; he's gone. Everything was gone. His shoes, everything that he was wearing was just totally vaporized. So it's a sad story, but it's just an indication of how much we ought to respect the power of electrical energy. So remember, electricity always follows the closest path to the ground. And so, please do not be that path. So, for example, here you are, here's the field, here is a tree, not my best tree, but it is a tree, you get the idea, and you are out in the field, and there is a lightning storm happening. What do you do? Well, one thing you don't do is you don't go to seek shelter under this tree, because this is higher than you are. And so the chances are, it's not 100% guaranteed, but the chances are the lightning strike will hit this before it hits you. If you wanted to minimize your chances of being hit, what would you do? I don't know about you, but I think I'd lie down. I'd lie down flat, because This is still a shorter path than that, but you would not sit in there. Okay? Okay, now I think the last word is a bit about semiconductors, and then I'm handing the ball off to you. Semiconductors, we've talked about these guys before when we talked about chemistry. Semiconductors just allow electrons to move, but there is some resistance, and the resistance changes, and so the ability, I'm going to do this in red, the ability to move depends on temperature. Now, intuitively, if you increase the temperature, this will lead to greater movement. We call movement of electrons current. Okay? If you decrease the temperature, this will lessen it. Okay? And that's why a lot of modern electronics use semiconductors as well as, I don't know, semiconductors as well as both conductors. And insulators. Examples are silicon, and germanium. Silicon is cheaper, so we tend to use that. Okay, now from here on in, the next 2 pages is for you to read. You need to read pages 27 to 29, or 281, and the answers to these are embedded in the reading material. The same is true with 9.5, and that will complete the today's work. And that's it. That's it for you today. How do you like that? 13, maybe 14 minutes of video time, and probably about 15 minutes of work on your own, and you're done for the day. You can use your time with however you want. Okay, I will see you next day. Love you guys. Bye now.